So today we will start a new chapter called Anomaly Detection in Graphs. So this is the 8th chapter of this course, Social Network Analysis, and so far we have learned almost the fundamental concepts that are needed to understand this chapter. The prerequisite for this chapter is hopefully you have already learned the link analysis part, the link prediction part, the community detection, the clustering, the clustering algorithm of a network, and a bit of centralities and all these stuffs. So in the last chapter we have discussed one important application, which was how information spreads on social network, how cascade grows on social network, and what are the factors which lead to a growth of a cascade on online social network. And that application was important in the concept of, in the context of, say, virality prediction, right? So you want to predict the virality of a particular information, of a particular tweet, for example. So what would be the approaches based on which you can predict the virality or a cascade growth, right? Now, sometimes when we talk about virality or information spread, we also look at who is spreading the information, right? Which user is responsible for spreading, say, a malicious information, say fake news or misinformation or hate speech, right? And we try to identify bad actors, right, in the context of social network, and try to reason about how such bad actors start spreading information, and how this spread is different from the normal spread, right? So in this chapter we look at how we identify nodes or users which are abnormal, which are different from the rest of the network, right, with respect to some application. This application can be fraud detection, application can be say credit card transaction, fraud transaction detection, and so on and so forth. Okay. All right. So to begin with, these are the two survey papers which we are going to follow, and these are heavily cited survey papers on graph anomaly detection. So you may want to look at these survey papers appropriately. Okay. And the slide, the slides, today's slide is based on these two survey papers. So I will try to give you a brief of the methods that we generally follow for anomaly detection. But if you really want to go deeper into the methods, each and every method, you should look at the survey papers. I will try to cover some important algorithms which are generally used for graph anomaly detection, but of course those few algorithms are not enough. You can look at these survey papers. Okay. All right. So if you look at the anomaly detection problem in general, right, it is basically about identifying rare events, okay, infrequent events, right? And when we talk about infrequent or rare events, if you look at the entire population, right, for example, if you look at Twitter or Facebook in general, millions of users, billions of relations, right, and from billions of relations or millions of nodes or users, it would be extremely difficult to spot anomalous nodes or outlier activities, right? And if you look at the population, it's basically say 1% of the entire population. Anomalous behavior is 1%, even less than 1% of the entire population. So it is extremely difficult to identify, to spot anomalous behavior in the context of social network, and not in the context of social network, but in general. If you look at any outlier detection applications, right, generally the proportion of outlier data points is much lesser than the genuine data points. So it is essentially mining needle in a haystack, right? So essentially you have huge population, and from this massive population, your task could be to spot bad users, bad actors, right, inorganic activities, right, fraud activities, right, in a systematic manner. And there are multiple challenges associated with anomaly detection that we will discuss in the later part of these slides. Okay. So what is anomaly? Anomaly is a pattern in the data that does not conform to the expected behavior. Now, this is a very vague definition. In fact, we will talk about many such vague definitions, right, which may not make much sense without identifying the context, right. So, first we identify the context, the application, and then we define what do we mean by anomaly, anomalous behavior or anomalous entities with respect to that context. Okay. So, this anomaly, the term anomaly can also be referred to as outliers or exceptions or peculiarities or surprises and etc. Remember, when we talk about anomaly detection, it does not always refer to bad activities or fraud activities or ingenuine or inorganic activities. Anomalous behavior can also be exceptionally good behavior. Okay. For example, if you think of a citation network or researchers network, right, or scientific articles and their relations, right, through citations. Anomalous nodes are those papers which have been exceptionally highly cited, right. Anomalous researchers are those researchers who have heavily been cited, who have received a lot of awards, who are say Nobel laureates, for example, because their behavior is very different from the normal behavior, right. If you look at the population in general, so Nobel laureates research activities or their publications, their innovations, right, are very different from the normal behavior. So, it is not the case that anomalous nodes are always bad actors, right. Anomalous nodes or anomalous users are those which behave very differently from the rest of the population. Okay. This is very important to note. Okay. So, it has so the problem of anomaly detection has numerous high impact. For example, in case of say fraud detection, right, or in case of say fake news detection, right. Even if the amount of fake news that are being spread every day compared to the real news is much lesser, but the impact that this fake news creates, right, or makes on the society in general is huge, right. We have seen cases like communal riots, right, violence, even death cases because of the fake news. So, particularly in the context of COVID-19, where this misinformation about health related tips, right, has spread, and people basically adopted those advice, and that again has led to even death, right. So, therefore, this is very important, and our task could be identify anomalous behavior from social network. We will particularly look at social network, but the techniques that we will discuss might also be useful for other kind of networks as well. Okay. So, now let us look at some of the real world applications, right. Credit card frauds, right. If you look at the abnormally high purchase made through a credit card, right, you can say that this is kind of anomalous behavior. Similarly, in the context of cyber intrusion, if you look at some sort of involved web server involved in say FTP traffic, this can also be a potential threat, right. Of course, fake followers, fake retweeters, fake reviews, these all come under the broad umbrella of anomaly detection. Okay. Apart from this, we have a series of applications. For example, calling card and telecommunication fraud, auto insurance fraud, email and web spam, the spam detection methods, right, opinion deception and review spam. If you look at the say e-commerce services like Flipkart, Amazon, the kind of reviews that people generally write, many of them are frauds, right, fraud reviews. Even people do not buy products, but they write reviews, right. Auction fraud, tax evasion, customer activity monitoring and user profiling. Fraud clicks, right, is clickbait is something which is again is under the broad umbrella of outlier detection. Then malware and spyware detection, false advertisement and image video surveillance, all these applications come under under the broad umbrella of anomaly detection or outlier detection. Okay. All right. So now let us look at the difference between outlier detection and graph anomalies. So outlier detection is generally studied in data mining, and you must have heard about techniques where we given an embedding given a embedded space or any Euclidean space, data points are mapped and you try to identify those data points which are say further apart from the other data points, right. This is basically outlier detection in the context of data mining, right. But here we will mostly talk about graph centric anomaly detection. Okay. Now why graph centric detection is useful? Why graph is useful in the case of anomaly detection? So the reason is as follows. Let us take an example of say reviewer fraud detection, right. You have a product and you look at the reviews of the product and ratings of the product are given by different users, and your task is to identify those reviews which are fraud, right, or fake, right. Now if you look at reviews individually, right, individually in the sense like it is not the case that you look at one review and you analyze the second review with respect to the first review. You are looking at reviews independently, okay, as if they are sampled from an IID, right. So if you look at reviews, right, a fraud review in general looks like a genuine review, right. For example, it may talk about the some problems in the product, right, delivery related or features related problems, right, and therefore automatically the rating is low, right, 1 or say 2 out of 5. Now how do you know that this review is actually a fraud review, okay, without looking at other reviews, right. Similarly, if you think of another setting where you look at all the reviews and try to understand their relations, right, which review is similar to which other reviews, right, and you also look at the patterns when these reviews have been posted, right, their rating behavior, right, and so on and so forth, you might find some cases where reviews, the text, the semantics, the text, the content of the reviews is almost same, right. They are posted at the same time and the corresponding ratings are also same, right. Their content is same, their rating is also almost same, they are also posted around the same time. Then you may wonder that how has it happened, right, because how could users write similar kind of reviews, very similar kind of reviews with same ratings at the same time, right. So you are looking at the interdependencies between reviews, right, with respect to the content, with respect to the rating, with respect to the time. So there is a synchronicity in terms of the content, rating and time, and maybe some other features as well, right. And then you may wonder that possibly this set of reviews have been posted by the same set of users. There might be a collusion between reviewers, right, between users. They might have been paid to write fraud reviews about the product, right. Again, remember, when we talk about anomaly detection, right, it can also be genuine reviews, right, in the sense like not a genuine reviews but very high quality reviews on a particular product, but there might also be some collusion, right, behind these kind of activities. For example, a product, the seller of the product, the seller wants to boost the rating of the product, right. He or she may hire a set of reviewers, right, a set of users who would start writing good quality reviews about the product with heavy ratings, right. Those are also anomalous, okay. So, why graph is important? Because graph structure would give you the ideas about the dependencies of reviews, right, the dependencies of users, the dependencies of ratings, right, in some ways. This interrelations has it can easily be captured using graphs, right, in contrast to if you just look at the embedding space and data points in isolation, you won't be able to identify the dependencies, right. So, therefore, graph plays a very important role in modeling the anomalous behavior detection task, right. Okay. So, now let's look at the challenges and opportunities, right. The major challenge or the major opportunity is lies in terms of the definition itself, right. I mentioned in the chapter of community detection that the community detection problem itself is an ill-defined problem. It is not an well-defined problem because what is a community is not very well defined, it is not very clear, right. I can define in my own way, you can also define in your own way, and that is challenging and that is also opportunity because you can come up with your own definition, and if you convince others that this definition makes sense, you can write papers, okay, you can design methods which can capture communities of your own type. Here also anomaly detection is an ill-defined problem. There is no unique definition of what do I mean by anomaly detection, right, in the context of a particular application, right. So, what we generally do, we take an application and we define a meaningful definition of an anomaly, and then we design methods to identify that kind of anomalous behavior. So, now let us look at the this Hawking's definition of outlier, which was proposed in 1980. It basically says that an outlier is an observation that differs so much from the other observations as to arouse suspicion that it was generated by a different mechanism. The definition is little complicated, but do not worry, I mean we will try to make it simple. Okay. So, let us define the task of graph anomaly detection problem as follows. So, you are given a graph. The graph can be a plane graph or an attributed graph, it can be a static graph or a dynamic graph, and what is the task? The task is to find graph objects, nodes, edges or subgraphs that are rare and that differ significantly from the majority of the reference objects in the graph. Okay. So, a graph object is flagged as anomalous if its rarity, likelihood, outlierness score exceeds a user defined or an estimated threshold. Okay. So, we will define what do we mean by rarity, what do we mean by likelihood, what do we mean by outlierness, right, again with respect to an application. Okay. So, point is anomalous if it is rare, right, a rare combination of categorical attribute values, right, it is isolated, it is far apart points, right, and they are far apart points in a n dimensional space, and there is some sort of surprising factor, right, and of course a data point needs too many bits to describe under a minimum description length principle. Now, this is something that we will avoid in this particular chapter because it requires lot of understanding of information theory, which we will not discuss, but one can also look at entropy, information gain and so on and so forth to encode data points using bits, and then we can detect anomalous behavior or outlier behavior. Okay. Right. So, now let us look at some of the major challenges. So, the first challenge lies in the data specific aspect of the problem. So the scale or the dynamics of the data point itself is a problem. We have huge data point, right, which are publicly available. Now from this huge data point, how can we identify data points which are very rare, right? This is a problem, and the other problem is the complexity. If you look at the user demographics, interest, role, as well as different relations, right, we need to consider all these aspects together, right. So the complexity increases as we incorporate more and more features, more and more attributes in the outlier detection problem, right. Okay. Now let us look at the other challenges. The second challenge lies in the problem itself, right. If you look at the problem, the outlier detection problem, it is basically an classification problem, but it is, and it has huge class imbalance. You have 0.1% or 1% population which is outlier, and remaining 99.5%, 99% population is non-outlier, right. This is a problem. So now how do we tackle it? We will discuss, I mean, we can use say class imbalance problem specific task, right. If we take say classifier which handles the class imbalance problems in an intrinsic way, and that may solve the problem, but when it comes to graphs, right, those methods may not be enough, right. The second aspect is the asymmetric error. What do you mean by this? What is asymmetric error? Okay, so if you look at the cost, right, when we identify or when we manually identify anomalous behavior, right, if we wrongly identify an anomalous node, right, the cost may be detrimental. For example, if we misclassify a cancer patient as a healthy patient, right, the effect can be a fatal consequence, right, it can have a fatal consequence. If we misclassify an honest customer as a fraudulent customer, you can lose out, you may lose out, the customer's loyalty or customer's trust on the platform itself, right. So there is no luxury of annotating data points in a wrong manner, right, in an erroneous manner, which may lead to some detrimental consequence, right. Okay. So the other problem specific challenges include the anomaly detection problem. The anomalous behavior itself is novel. Why? Because these fraudulent customers or fraudulent users, they keep on changing their behaviors over time. So say let's say today, if you come up with a method that can detect fraud activities, right, that method may not be enough tomorrow to detect fraud activities, because meanwhile it may happen that the fraud activity has completely changed. The way people behave, the way fraudulent users behave, that may change drastically. In fact our lab, so we have been working on this fraud detection problem since last 3-4 years, and one of the questions that people generally ask is that, let's say a fraudulent users, right, will read our paper and will understand how we detect fraud behavior, and they change their behavior tomorrow, right. How would your method, which has been designed yesterday, that method would be able to identify the evolved behavior, right. And that is very difficult to answer, because I mean, I generally answer in the following way. I can say that, look, remember, fraudulent users, they don't have enough resources, right, they don't have enough say computing facilities or enough scientific knowledge to understand the behavior well. So meanwhile, when they change their behavior, since we keep on collecting data points online, right, meanwhile it may happen that we will also adapt we will also modify our algorithm and try to capture their behavior, their evolved behavior, right. Okay, so the second challenge is the explainability. So when we pinpoint, when we say that look, this user or this behavior is a fraudulent behavior, you may be challenged, right. So you have to explain why you were saying that this guy is a fraud guy, why this activity is a fraud activity, right. So your model should be able to explain, right, the result in an appropriate manner, so that people will understand, the reason behind the class label that you predict. Okay. So these are the major challenges, these are the major opportunities, I would say, and therefore this problem is extremely interesting in the context of data mining as well as social network analysis. So hopefully I was able to motivate you why outlier detection is an important problem, anomaly detection is an important problem. So we stop here. In the next lecture, we will start discussing about important algorithms. We try to come up with a taxonomy of anomaly detection algorithms, and then we start looking at important algorithms, both in terms of like the way people approach this problem, and how you can use modern techniques to design your own methods of detecting outliers from a graph. Okay, thank you.